So there are some rules that apply for fractional indices, and again these will apply for a base of a and a power of m. Now in this case they need to be a fractional power, so 1 over m. And whenever we've got something in this form, that means you've got the mth root of a. Okay, so if we had 5 to the power of a third, that would be the cube root of a, or of 5, cube root or the third root. If we had 7 to the power of a quarter, that would be the fourth root of 7. Now whenever we consider the power of a half, we could write it as the square root of 3 with the number 2, but it's a lot more common for us to just write it as the square root of 3 without the number 2 there. The square root is the most basic form of square root, so we don't need the 2. So anytime we see a square root sign without a number, we know that it means the square root. So that would be a power of a half. The other fractional rule is whenever we've got a to the power of n over m. So it's very similar to the last one. So it is going to be contained with the mth root of a, but then it's going to be raised to the power of n. That's one form of doing it. The other way is doing it as the mth root of a to the power of n. And this is really coming from our bracket rule from before, because we could write a to the power of n over m as a to the power of 1 over m to the power of n. So we're multiplying those two together to get n over m. So we do the mth root first and then we raise it to the power of n. Or we could do it as a to the power of n times by the 1 over m. So we're raising the power first and then we're taking the square root. So we'll look at the examples on these. Example A. We've got 25 to the power of a half and we're trying to evaluate these. Now whenever it comes to evaluating these, it should be a fairly straightforward process. It should be 2, 3, 5, 7, something quite straightforward that you can do without a calculator. So 25 to the power of a half, that's going to be the 1 over m rule that we'll use, and that's going to equal the square root of 25, which we all know to be 5. Part B, we've got 32 to the power of 0.4. Now sometimes these fractional rules can be used for decimals, and the way we do that is we express 0.4 as a fraction, and we know that to be 32 to the power of 4/10, which simplifies to 32 to the power of 2/5. So we've got a base number of 32 raised to the power of 2/5. That's going to be of the form a to the n over m. So that's going to give us the 5th root of 32 raised to the power of 2. Now the 5th root of 32, you might be thinking that seems quite complicated, but remember I said it was going to be easy numbers, and if we think of 2 to the power of 1 is 2, 2 squared is 4, 2 cubed is 8, 2 to the 4 is 16, and 2 to the 5 is 32. So the 5th root of 32 is 2, and then we need to square that, and we get 4. Example C, we have 64 to the power of minus 2/3. Now the minus we've seen before, and that goes to 1 over the 64 to the positive 2/3. So we've got a fraction here. We could then have to write the 64 to the power of 2/3 using this previous rule, or using this rule, and that's going to be 1 over the cube root of 64 squared. Cube root of 64 is 4, so it's 1 over 4 squared, which is a 16th. Now more often than not we'll do the cube root or the 5th root first of all, because it's much easier to reduce that to a smaller number rather than squaring the 64 to get quite a big number and trying to figure out the cube root of that. There are occasions that we will do the power first of all before the root, but we should always try taking the root first of all. Okay, so the next set of examples, what we're trying to do is write in index form, and that starts off as the cube root of 5. And the cube root of 5, well, we can see that it's of this form, this rule, where 3 is the value of m and a is the base 5. So we can write that as 5 to the power of 1 over 3. Part B is the fourth root of e cubed. And again, this looks like our fractional rule here. So we've got e to the power of 3 on the fourth root. And that's going to go to e. The power of e is on the numerator, so we can see that's the power of a, and it's on the numerator, and the denominator is going to be 4. So whatever the root value is on the denominator, and the power is the numerator. Example C, we've got 1 over the square root of b, and it's just the square root. So if we deal with it in its current form, the square root of b, so here was in our example was the square root of 3, was 3 to the power of a half, so that's going to be 1 over b to the power of a half. But we want to write it in terms of a base, so we want to write it as b to some power, and whenever we've got 1 over, we can express that in terms of a negative power. The negative rule, we used it here to express 64 to the minus 2/3 as 1 over 64 to the 2/3, so we're going to use that in reverse, and it's going to be b to the negative half. Example D, we have a over the fifth root of a cubed. So the denominator, let's work with that. The fifth root, so the root is the denominator, the power is the numerator, so that's going to be a to the power of 3 over 5. There's a couple of ways we could go about this. We'll go about it by dividing, so a fraction means the top divided by the bottom. So that's going to be a divided by a to the 3/5. Now remember, this first a has a power of 1. So it wasn't included there, but we need to add it in for whenever we're manipulating the indices. Our rules for dividing are taken away, so 1 whole, take away 3/5 is going to be 2/5. Now I said there was 2 different ways in which we could have solved this. The other way would have been to use our negative rule. So this would have been a over a to the 3 over 5, and we could have expressed that as a multiplied by a to the negative 3/5. So the power on the bottom, if we want to bring it up, is going to be to the minus. A has a power of 1, and then when we're multiplying we add the indices, so 1 add negative 3/5 is 1 take away 3/5, so it's a to the power of 2/5.